So this is just a video talking through the work of my post. Here's our problem. The key thing is drawing a picture, and we need to label things. So the black dot is about Mount Rainier, is 56 kilometers east, 40 south, where the point is 56, negative 40 based on the axis I drew. This is we start here and we fly down to this blue point. And of course the blue point is 130 kilometers east and 147 kilometers south, which corresponds to that point. And this red line, our path of the flight, we can put a equation to it. We know the slope's negative 147 over 39. It goes through the origin, so the y-intercept is 0. So it has a really nice, beautiful, easy equation. And now the next thing we do is draw a line. We want to see how close this is. If we just eye it, right here is about as close as we've gotten to Mount Rainier. And of course that's a perpendicular line. Kind of here's the zoomed in picture. We know since it's perpendicular, since this slope is negative 147 over 39, the slope of the perpendicular line is 139 over 147. We still know that this is 56, negative 40. That's the black point. We have a slope, we have a point. We can easily find the equation of the line. And the key thing is figuring out this green dot right here. We just need to know where they intersect. So here's our equation, our two equations. This is the red line, this is the black line. So we just need to figure out where they intersect. We do that by solving this system. Solve this for y, set it equal to this, and figure out what x is, etc. And remember what the question was: how long after you depart from Joint Base Lewis-McChord will you be closest to Mount Rainier? If we can find out what that point is, we can find out how long this blue length is. That's how long the distance, not time, but the distance we flew before we're close to Mount Rainier. And then once we know the distance, we can figure out the time. So I'm not going to finish the problem because after this is relatively basic algebra, but getting to knowing that we need to solve this system right here is the big work of the problem.